All right, this video is going to be on finding the characteristics of piecewise functions. So I'm giving you a graph to start with because we're going to assume that we can graph these correctly, hopefully. And then once you have it graphed, there are some things that we're going to find kind of our characteristics or like our descriptors of the graph. So first, we're just going to make sure that we know how to evaluate a piecewise function. And I actually didn't notice this, I mixed notation on my worksheet on accident. So go ahead and change that to be f of x. So here it says f of -6, and so we have to figure out which piece we can plug -6 into. So -6 is less than 4, and that means I'm going to plug it into the first piece. So -6 minus 2 is -8. So f of -6 equals -8. If I plug in -2, I'm going to be plugging that into the same piece. So then I would say -2 minus 2 is -4. 0, we're still less than 4, so that's going to be plugged into the same piece. So 0 minus 2 is -2. But 4 is actually the point where this changes, so we have to think about which one of these pieces am I supposed to use if I have 4 exactly, and that is the second piece. And the second piece just says it's 0. So f of 4 is 0. If I want to plug in 100, that's bigger than 4, so I'm going to get 0 for that as well. Okay, so next we're talking about domain and range. So the domain are the x values that you can see on the graph. So if I look from left to right, if you guys can see, there's part of the graph right there. It's just kind of, it's on the x-axis, so it's hard to see. So from the domain, I can see that left arrow, so I know it goes left forever. And then I've got all these negative values, and I've got the positive values, and I think that maybe the x value of 4 is not there. But then I look down here and I can see that the x value of 4 is included. It's just included on this second part. So I do have 4, and then I do have all these positive numbers, and then I have a right arrow. And so my domain is from -infinity to +infinity. There were no x values that were skipped. All right. For my range, I'm going to look from down to up. So if I look down, I can see an arrow going down, which is a -infinity. And then as I go up, I see all these negative y values, and then I see a y value of 0, and then I see some positive y values, and then it stops at a y value of 2. So here I have to figure out if I should have a parenthesis or a bracket. I'm going to use a parenthesis because that dot is not filled in. So that point is not actually there. We've got 1.99999, but not 2. Right, next I'm going to do my increasing and decreasing intervals. So I'm going to put my little stick figure right here. And I can see that he is increasing. He's walking uphill until he hits this hole and he falls into the hole and then he dies. And so then we start a new stick figure right here. And this stick figure, he's not walking up, he's not walking down, he's just walking like straight. And so we would call this actually constant. And constant doesn't happen very much, which is why it's not on the sheet. But every so often when it does happen, you can just go ahead and write that anyway. Okay, so now I'm going to fill in my x values. I have a left arrow, which is -infinity. This is an x value of 4. This is also an x value of 4. This is an x value of +infinity. So for my increasing interval, I'm going to say from -infinity to 4. And then over here for decreasing, I'm going to say none. And I'm going to add one more. I'm going to say, what if we have a constant interval? That constant interval is from 4 to infinity. All right. Does this graph have a max or a min? We're going to say no. There's no high point or low point. Like max would be like I'm looking for something that looks like a mountaintop. Min is like I'm looking for something that looks like the bottom of a valley. Neither one of those things happens, and so I don't have any of those. Intercepts. We have an x-intercept at 2, 0, And then that whole graph is kind of like an x-intercept, and honestly, I don't know how to write that, so we're just gonna leave that part blank. So x-intercept at 2, we also have a y-intercept at -2, so 0, -2. Now, this is the first time we have dealt with a graph that is not continuous, and a lot of you guys have asked me how we know if it's not, and the answer is when you trace it with your finger, you have to pick up your finger to trace the whole graph. So if I start here, I would trace, and then I have to pick up my finger and come down here, and then I can trace some more. So this graph is not continuous because I have to pick up my finger. And we will find that piecewise functions are often not continuous. There's typically a little gap in there. All right, so for end behavior, we're going to look as x goes to the left and as x goes to the right. So as I look to the left forever, I can see that the arrow is going down. So that means that the y coordinate is -infinity. It's going down forever. As I look to the right forever, the y value is not going up, it's not going down, it's actually staying at that value right there, which was 0. So I'm going to say y goes to 0. So that's the first time we've seen one that goes to a number instead of an infinity. And you might write a little note to yourself that this happens whenever you have a horizontal line. So the end behavior is that it goes to 0. All right. So for the next one, if we want to plug in -6, -6 is less than -4. And so we're going to do -6 plus 4 equals -2. If I want to plug in -4 exactly, I have this piece and this piece that have the -4s, and I have to think about the one where it can equal -4, which again is the top piece. So I've got -4 plus 4 equals 0. If I want to plug in 0, I'm going to do that in this middle piece. So I have negative times the absolute value of 0. 0 written as a positive number is still 0, and -0 is the same thing as just regular 0. And then here I'm going to plug in 11. That's going to be the third piece because that's bigger than 1. So I have 11 minus 2 cubed is 9 cubed, which is 81 times 9. I think that's bigger than I know. I think it is. Let me type that in. 9 to the third, 729. It's a big number. All right. So now we're going to check the domain. We're going to look from left to right. So starting at the left, I have all these negative values. It looks like we're including -4. And then I've got all these negative values. I've got 0. I've got my positive x values. And then it goes right forever. So my domain is from -infinity to +infinity. For range, we're going to go from down to up. So this arrow points down, so it goes down forever. You can extend the line if you want to show that it keeps going. So it goes down forever. We got some weird stuff happening in the middle, but we use all these points. All these y values are being used, and then it goes up forever. And so that means the range is -infinity to infinity. I'm going to go ahead and label my graph. So I have my stick figure who's walking uphill, and then he falls off and disappears. And then we have this stick figure who's walking uphill, and then he hits this point, and then he goes down for just a little bit, and then he goes up, and it flattens out, and then he keeps going up. So this is all increasing right here. So we're going to say that this is -infinity, so he increases starting at -infinity up to -4. And then this is from -4 to 0, and then from 0 to 1, and then from 1 to infinity. So the increasing interval is from -infinity to -4, and -4 to 0, and then 1 to infinity. And the decreasing interval is very, very short. It's just from 0 to 1. This graph does have a max. It has a little high point right here. And so we have a max at 0, 0. The graph also has a min. We have a little low point right here. The min is right 1, down 1. So 1, negative 1. We have a couple intercepts. I can see an intercept at negative 4, 0, 0, and then positive 2. On the y-axis, we have an intercept of 0, 0, but I already wrote that one down. This graph, if we were to trace it with our finger, we have to pick our finger up to trace part of it. So we're going to say, no, it is not continuous. And then for end behavior, I'm going to say, as I look to the left and as I look to the right. So as I look to the left, the arrow goes down. Y goes to negative infinity. As I look to the right, the arrow goes up. So that's positive infinity. All right, and you do not need to do the problem on the opposite side. We're going to do that in class tomorrow.